Hey there, I'm St-Pierre, and you're listening to Go Podcast. Today, in the episode 3, we will talk about pointers, stack, and heap. Hey, thanks for listening and returning back. Just before we start, it would be extremely helpful if you can share the podcast. And with that said, let's jump right in on our main topic for today, which is pointers, the favorite topic of most people. But joke aside, I think pointers have a kind of a bad reputation, or at least they might be misunderstood from developers that have not done any kind of C programming in the past. So I think due to the way memory allocation is done in C, I think pointers got some bad reputation about that. But let's talk about what they are in Go, because they are not to be afraid at all. In fact, what is a pointer actually? So you need to understand first what is a variable. In fact, when you say var I int equal 10, for example, so you are basically declaring a variable that holds the integer value 10. So from the runtime point of view, this value is there inside this variable. When you are declaring a pointer, the value that is held inside the pointer is the address of the memory that this pointer points to. So if the pointer is a pointer to an int, for example, then instead of holding the 10 value, it holds the start of the memory that holds this integer value, this int64 value, for example. So you have to think about that that way. It's nothing more. It's nothing complicated. In fact, it's just that. It's just something that remembers where where the start of the memory is for the specific values that this thing is pointing on. All right, then, so when to use a pointer, you might ask. Then this is a good question. Let's see, in my opinion, where using a pointer would not be a good option. Well, it's personal. I mean, I am just giving my opinion here. Anytime that you need to change a value that the pointer points to. Let's take an example. Imagine we have a function ABC that would receive a pointer to an int. So we have a function ABC that receives a pointer high, which is a pointer to an int. If in your body of your function ABC, you need to change the value of I. So now you cannot just say I equal 15. So let's say we call ABC with 10. So ABC open paren 10. So that is not valid because we are not passing a pointer to our function. So we now need to declare an int, and we need to pass a pointer to this. So let's say we say var high equal 10, and now we call ABC with the ampersand just before the I. So this means that I want to pass the address of this variable instead of the value. So for people that comes from .NET or Java, it's passing. It's similar to passing variable by reference. So even though especially in the .NET world, we are not really talking about pointer, but when we are passing thing by reference, it's a pointer at the end of the day. It's the same idea, but they just cleverly not call that this way. So people, I don't know, people does not really think about that much. But let's continue with our example. So we have var high int equal 10, and we are calling our ABC. We pass the ampersand. So we say pass the address of that variable. So if we want to change the value inside our ABC function of this high, we need to difference it by using the star before the I. So we could not say in our function ABC high equal 15, for example, because it's not, we cannot put the value 15 into a pointer. The pointer is waiting for an address in memory and not an int64 value, even though it is pointing to an int64 value. So my first answer of when it would not be preferable to use a pointer, if you are finding yourself differencing a lot of pointer, meaning that you put a star. So we would put star high equal 15. Now we are differencing the pointer. We are changing its value inside the memory, and the caller now, if they are using the high, they will have 15 in there. So personally, I don't like differencing. I don't like reading code that are differencing pointer a lot. I think it is like code smell and whatnot. So this is one example that I would simply pass the variable high into my ABC, and I would return a new int. So that would be how I would do that instead of differencing. Yeah, I just noting I was saying the word differencing. I meant dereferencing. So sorry, I'm not an English speaking. So bear with me. And I don't really want to retake all this previous segment. So yeah, I was meaning dereferencing. All right. So when you think about that, if you use the encoding package to encode, to decode JSON, for example, or any kind of type, we are passing a pointer. So this is a great example of passing a pointer. You want your variable that the pointer points to be changed by the function, and the function just change it, and that's great. So that's a good option. If you are thinking about, let's say, should I use a pointer for my structure or not? So this is kind of an easy one to insert. If you need to share the fields that the structure have across your application, and when I mean sharing, I mean that you want to let other functions change the field of the structure, and that anyone else that is using the structure is getting this change. Using a pointer is a good option, but we need to be careful with that, because now we are entering into this JavaScript-esque global variable that can be changed everywhere, and now it could add some complexity regarding the state of your application, because now everyone that do have access to this structure by the virtue that it is a pointer, they could change the fields in there, and you need to be careful. This needs to be really thought through carefully, I think. But sometimes you don't really have an option. Sometimes this is the way to go, and if you are going to use that, then yeah, just keep in mind that yes, you need to be careful. Another thing to be careful at is when using a for loop over a slice, and inside your for range, you would call a function with passing a pointer to the variable that holds the current item on the slice. So since you are passing a pointer, you are not passing the value. Instead, in fact, you're really passing the address of this value. And this might be surprising. It might not do the result that you are expecting. So just be careful with that. In fact, it boils down to the majority of the time you will probably not use a pointer. So you really need to think, especially for function. So for function, it's basically that. Are you going to change the value inside what you are receiving in parameter? And if yes, is it, would not be better to just return this new value in the return type instead of having to mess with pointer? Another useful use case of pointer is when you need to differentiate between a default value, a zero value, and not setting a value at all. So let's say you have a struct person, for example, with first name, last name, and email, for example, and you would like to know that, okay, this instance of a variable has not been set at all. So that's a good way to use a pointer. The downside, though, is that now you are forced to check for the nil everywhere. So yeah, again, we are returning to don't shoot yourself in the foot. So if you really need to do that, then that's good. But you now have to make sure that you don't have nil pointer anywhere, and you are not using any field with that could be dangerously panicking your application because the pointer is nil and now you're using a struct in that. So that's something to think about. When you are declaring a variable, they are real variable. So I mean, if you are declaring a slice and you pass that to a function, and the function modify or add a value in the slide, what will be the result in the caller? They will not have this new item that have been added in the function if you're not using a pointer. This is true for all types except maps. When you're passing a map to a function, if there is an addition or removal in the map, then you will have this change on the caller, because map are basically pointer at the end. Same for function, but yeah, something also something to keep in mind. Everything else, if you need to change a slice in a function, then you probably need to pass a pointer. Lastly, is it more performant to use a pointer or not? And the answer is probably not. And for that, without going into too much detail, we still need to understand what how memories works a little bit when you are executing your program. It might not ring any bell at all, but keep with me. It's not that complicated. So when you are running your application, you have a special place in memory called the stack for your application and the heap. So you might have heard about those words before. Basically, the stack is used to store all the variable that you are running during the current execution of the function. So let's say you are calling a function ABC, and this function declares 3 variables, then they will be allocated into the stack. And once this function exits, the stack, those 3 variables are just freed automatically. So that's basically cheap as in terms of operation. And when you are using a pointer, so since other functions and execution needs to be aware of that values and potentially change it and whatnot. So this this is going to be saved into the heap now. So this is a little bit more costly in terms of operation, because at some time it might need to go to the OS and require for a little bit more memory and whatnot. And this is where the garbage collector as well needs to do lots of work, because now it needs to understand, okay, yeah, this pointer is not used anymore, and all the references to that pointer does not exist, so I can garbage collect it now. So all of that just to say that, well, no, it's probably not an optimization, and you should not think of pointer like that. It's minimal, and probably not going to change anything at all. So without too much theory and whatnot, I think it's kind of important to just understand that, and yes, the rule of thumbs is, just use them when it makes sense, and it will come as you go, when as you write more Go code. All right, that's it for this week. I hope you liked the episode, and again, if you can share and talk about the podcast, that would be extremely appreciated. Also, if you want to check my book out, I have a course named Build SaaS App in Go. So it's at buildsasappingo.com. All right, see you in 2 weeks. Bye.